All right, so we're going to look at an integral. This time is going to be a little bit more complicated. It's going to have um, trigonometric functions, and I know that causes a little bit of trouble. It's still going to require for us to do a u-substitution, but it may not be automatic for you to determine which is going to be your substitution. So you'll have two options. I'm going to write this cosine square of x, and you'll have to check. And that's a question I get often. How do I know which is the right substitution? And there's just really not a good answer. Usually you pick whatever is the ugliest thing that you're dealing with. And in this case, both are kind of not great. Often people also think whatever's in the denominator, that also is another approach people say, and in this case it's just not going to work. Because for example, if I would grab, and this is wrong, but we're going to say if u would be cosine square of x, for example. Ugly handwriting, by the way. Your derivative, and this is all wrong, so I'm gonna have to delete it. It's gonna be 2 times cosine. You first, the outermost function is the square, so you do your chain rule. So you're gonna drop the 2 and subtract 1 from the exponent, copy the cosine as it is, and then you're gonna multiply times the derivative of the inside. Derivative of the inside of the square is gonna be cosine. Derivative of the cosine is negative sine of x, and then you're gonna have dx. Okay, do you see that anywhere here? And the answer is no. So we are going to have to recheck our substitution. So we're going to delete all that. As I said, this is not going to work. But I wanted to show you why. So now, the real substitution that is going to work is going to be u equals tangent of x plus 1. All right, why is that going to work? Well, because notice that the derivative of the tangent is the secant squared. And derivative of 1 is 0. But with that, then you have to remember now that the secant squared is 1 divided by cosine squared. Those? Sure, why not? Cosine, that's what I wanted to write. Cosine square of x. And then if you multiply both sides by cosine square of x, you're going to have cosine square of x times du is going to be your dx. And that's what you're going to be substituting in for the dx. And that is going to look like this. You're going to have your integral. Now tangent of x plus 1, that right here is what I'm putting for in this parenthesis. So that's going to be your u squared over cosine square of x. And in place of dx, I'm going to write cosine square of x du. And you see that it was very nice because then that cosine square of x cancels. And then that substitution works nicely because you get u cubed du, u cubed, u squared du. I'm already integrating. And here you're going to be adding 1 to exponent where you get u cubed over 3 plus c. Then you just take back your substitution, which is going to be the tangent of x plus 1 cubed all over 3 plus c. All right, so that's one of them, and we'll do another example with trigonometric functions, so we see how they work. All right, so let's take a look at one example where we will have to do a little bit of algebra to figure the substitution. So let's do, for example, the cosine cubed. And here you say, okay, so how do I even use substitution? It seems kind of u equals cosine. Well, let's say, okay, again, this is not going to work, but we'll show why. So let's say cosine of x is our u. The u becomes negative sine of x dx, and I don't have a sign here, so that would not work. So let's try again. What else could we do? We could do, for example, u equals cosine squared. That one may work a little bit better, but we will still have a problem. Let's try that one. So I say now you do u equals cosine squared. Why? Well, because the cosine didn't work. Might as well try the cosine square, right? So 2 cosine x times negative sine x dx. I still need a sine, so it doesn't work. So let me show you how you fix that problem. So the problem gets fixed whenever you rewrite this expression. That's why I said we had to do some little bit of algebra, and that's why I brought up the cosine square first. So we think about it for 1 second, or we can use that as a springboard for whatever we're going to do here. And so you write it like that. And then what do? Well, you remember that the cosine squared by the Pythagorean identity, let me write it as a note here, that cosine square of x plus sine square of x is equal to what? Well, x, the angle x is an angle in the unit circle, so this cosine and sine are coordinates, so being the unit circle, the sum of the squares has to be equal to 1, which is the radius square of the unit circle. Anyways, you know that Pythagorean identity, so that's what we're going to be using. And what we're going to do is we're going to subtract sine square on both sides, and I'm going to have cosine square is 1 minus sine squared of x. So I'm going to replace that here. All right, now that's very useful. Why? Because I can say, well, what if u equals sine? Well, du is cosine. And in this particular case, notice that this whole expression, you don't even have to do any solving. This becomes automatically the du. You don't have to do anything about it. Just write my substitution directly. 1 minus, and instead of sine, I'm going to write u. And instead of cosine x dx, du. And now I just integrate. When I integrate here, 1 gives me a u minus, add 1 to the exponent, so u cubed over 3. And don't forget your plus c. Always remember your plus c. And then take back your substitution. In this case, u is sine, so you get sine x minus sine cubed over 3 plus c. And that's going to give you your answer right there. All right, so that's that for this little video. So 2 examples with trigonometric functions. Not everyone's favorites.